Section 3.2. This is the remainder theorem. So the remainder theorem is a theorem for finding the remainder. Now, we already know how to find the remainder, remember? Let's say you've got this polynomial, and you want to divide it by this divisor. If I'm going to do it by long division, remember, I could do this. I could say, okay, x minus 2 divides into x cubed plus 0x squared. It's got to put in the 0 plus 5x minus 10, right? I remember doing this. Yeah, and x goes in this x squared times x cubed minus 2x squared. Subtract. I'm going to get 2x squared plus 5x. So plus 2x, sorry. So what do we get? So we get 2x squared minus 4x subtract. I'm going to get 9x minus 10. Last one's going to be plus 9, right? 9x minus 18, and when I subtract, I'm going to get positive 8. And you're probably thinking, why didn't you just do synthetic division? You're right, synthetic division is faster because it's a 1, right? I can use synthetic division in this case. 1x cubed, 0x squared, 5x minus 10. So instead of putting a minus 2 out here, I'm going to put a positive 2. That way I can add. So 1 comes down. 2 times 1, 2. Add them up, 2. 2 times 2, 4. Add them up, 9. 2 times 9, 18. Add them up, 8. There's my remainder. Now, you see the 1, 2, and the 9? Yeah, 1, 2, 9. That's where these came from. There's the 2, there's the 9, there's the 1, right? I'm just not showing all this stuff. So that's the beauty of synthetic division. If you keep them in order, 1, 2, and 9 are all there, and there's my remainder on the end. Okay, fantastic. Why don't we just take 2 and plug it into the polynomial? What do you mean? The polynomial was x cubed, 5x, and minus 10. So the polynomial, if I plug in 2, is 2 cubed plus 5 times 2, and then minus 10. In other words, it's 8 plus 10 minus 10, which is 8. It's the same thing. Why? This is a shortcut. Instead of doing the long division or instead of doing synthetic division, you can go straight to the remainder if you plug in the opposite number. What? Hang on. It was being divided by x minus 2, right? X minus a is usually the way they write it. I didn't plug in minus 2. I plugged in positive. I plugged in the opposite. Why? Here's why. Remember the multiplication statement. If you wanted to multiply this all out, remember the polynomial, which was the divisor x minus a times the quotient, which is a function of x, plus the remainder. Well, guess what? If it's x minus a, if I plug in p of a, I'm going to get a minus a times the q of a plus the remainder. A minus a is 0, and I don't know what this is. I don't care. So in other words, p of a is equal to the remainder. This is called the remainder theorem. So if the polynomial p of x is being divided by the divisor x minus a, then the remainder will be p of a. It's the opposite number because that way I get a minus a, which gives me 0. And when that becomes 0, this all disappears. I'm just left with the remainder. Fantastic. So that's the remainder theorem. Okay, so let's try this. Use the remainder theorem to determine the remainder when this polynomial is divided by x plus 4. I'm going to be plugging in minus 4. So in other words, the remainder is p of minus 4. In other words, it's negative 4 cubed minus 10 times negative 4 plus 6. So in other words, negative 4 cubed, which is negative 64, minus minus is plus 40 plus 6. So negative 24 plus 6, which is going to give me whatever it is, negative 18. Ta-da, that's the remainder. So verify your synthetic division. Let's see. If I'm going to do this by synthetic division, I would go 1, 0. There's 0x squareds, minus 10x's, and plus 6, right? Okay, so I'm not going to put a plus 4. I'm going to put a minus 4 out here. If I put minus 4, because the reason I'm doing that is because now I can add up my columns instead of subtracting. Okay, let's do it. 1. 1 times minus 4, minus 4. Minus 4, done. Minus 4 times minus 4, positive 16. Add them up. 6. negative 24, and there we go, negative 18. Ah, it is. Okay, how about this one? Find the remainder of, x to the power of 16. Now, if you're going to do it with synthetic division, right, you have to put in the zeros. 1x to the 16, 0x to the 15, 0x to the 14, 13, 12, 11, 10, 9, 8, 7, minus 9 for x to the 6s, 5, 4, 3, 2, 1, 9. That's what I have to be doing. That's an awful, let's not do that. I mean, that will work, but you know that, and I'm not even thinking about that thing as long division. If I want to know the polynomial's remainder, plug in -1. So it's just going to be -1 to the 16 minus 9 times -1 to the 6 plus -1 squared plus 9. They'll usually give you a nice number because something to the power of 16, look, I know this is an even, so that's just +1. This is even, so minus 9 times 1 plus 1 plus 9. 9's cancel. 1 and 1. The remainder is 2. I could have done the entire long thing by synthetic division. This is going to be my remainder. So this is just a shortcut for doing the remainder. Whoa, what about this one? Can I try this? Can I say not -1, it'd be +1, 1/2? Hang on, would that work? You couldn't do it with synthetic division, right? Hang on, let me try this. I'm not going to do it by synthetic division, but let's do it by long division, just because I remember how to do this. And it's, it's not that bad. It's a 4x squared minus 3x plus 6. Okay. So 2x goes into 4x squared 2x times. So 4x squared minus 2x. And when I subtract, 3 minus minus, this becomes minus 1x plus 6. Okay, so 2x goes into negative 1x minus a half of time, right? I'm going to half times 2. Okay, so let's give this a shot. Hang on, did I do this right? 4 minus 2, 3, 3, 3. Yeah, okay. So negative a half is going to give me negative 1x plus 1/2. So in other words, when I subtract, 6 minus a half is going to give me 5.5 or 5.5. That's the remainder. What if I had to plug this in? What do you mean? Let's take 1/2 and plug it in. Let's try it. 4 times positive a half squared minus 3 times positive a half plus 6. Okay, half squared is a quarter. 4 times a quarter is 4 quarters. In other words, that's 1. Minus 1.5 plus 6. In other words, this is 7 minus 1.5, which is 5.5, 5.5. It's the same thing. It does work. Now, I can use the not negative 1/2, but positive 1/2. The reason there is because this thing, right, if this is 2x minus 1, when I plug in positive a half, it still becomes 0. So yes, this does work. It doesn't work for synthetic division. If you wanted to do synthetic division, you have to do the long division, because either the remainder is going to be correct or the quotient is going to be correct. One of them is going to be right, one of them is going to be wrong. However, for the remainder theorem, you can use this. You can use positive a half. Okay. How about this? Here's some polynomial, k. When it's divided by this, it gives you a remainder of this. So it says figure out what k is. So in other words, I know the remainder is going to be positive 3 plugged in. So in other words, p of 3 is, let's plug in positive 3. So 3 cubed plus 2 times 3 squared minus 8 times 3 plus k. Okay, I don't know what k is, but I do know that the remainder is 17. That's this. So this is 17. This is 27. 9 plus 18 minus 24 plus k. Now it's just a matter of solving this equation. Oh, cool. Minus off 27, minus 10. This is going to give me minus 6 plus k. So in other words, add on 6. K is equal to -4. Ta-da! There we go. So the remainder theorem is simply a shortcut for finding the remainder. It doesn't tell you the quotient, but right now we don't care about the quotient. We only care about the remainder. Alrighty, so there's today's questions to work on. Not that many, but a few.